Hey everybody, it's Craig Maynard. I really like Mitch's challenge he's given you guys, these FTC challenges, CAD challenges, and it's really neat to see what you guys are coming up with in AutoCAD. I wanted to do one in SolidWorks. I'm a bit of a SolidWorks fan, and I'd like to show you how you could do something similar in SolidWorks, creating assemblies and linkages to make it move. Now, to do that, we have to come up with a way of creating a rotary to linear actuator. And a simple way to do it's like this. This is how I'm going to do it in this demonstration. We'll just get a single channel like this. Take that bushing out. A single channel like this. We'll put another channel inverted on top of it like that. And we're going to have it slide in and out like that. Okay, that's all we're going to do. We'll put a little stop on this side right here. Just use a bushing. Goes in there, so when it slides it bumps into the bushing. We're going to take a servo and mount it in its little servo holder that Tetrix provides. We're going to get a circular horn and we'll just mount that on top of the servo. We'll attach on a couple of swing arms, one like that and one like this, so as the servo turns the swing arm is going to move back and forth. And this end of the swing arm is going to attach onto our bracket. So as the swing arm moves back and forth, hopefully our real device will move back and forth too. So in the long run, it's going to end up looking like this. This is our SolidWorks model, and there it is moving back and forth. So that's what we're shooting for. So let's see how quickly I can do this. We'll just minimize that. Let's start by making a brand new assembly. So we're going to go new. We're going to create an assembly. We say OK. There we go. And we're going to go File. We'll just, always good to save it right away. So we'll save it as Craig's Button Pusher. Okay. Now, one thing I'd like to do is I'd like to see my origin. So I'm going to hide show. I'm going to choose go to hide show and choose origin so I can see the beginning. Now we're going to bring the parts we need in. So we're going to insert the components we need. So to do that, we're going to browse, and I'm going to find all the parts we need. So there's my little short channel. We'll bring that in and set it down. Doesn't matter where it goes. I'll just stick it right there. Okay, and we'll load in the other parts too I'm going to need. So let's see now. There's the horn, there's the servo. We'll bring those in. Bring that in. There's the servo holder. There's the little horn for the top of the servo. That looks good. Here's my little servo, plug that right there. I'm going to need another one of these, so I'm going to have to insert component. And up comes my selector box. And I choose a second bracket, so there's my second bracket like that, which is fine. Plunk it down there. And I want to have one of the long beams, and maybe a bushing too. So let's put in the long beam and the bushing. Where did I put all those? I think I stuck them into this directory. So there's my bushing and my long beam. Where'd it go? There it is, 288 millimeter channel. Just plunk that there, and I'll just plunk my channel over here. Okay, there's all the parts we need to build this thing. Now if you look over here on the sidebar, we can actually see the individual components showing up here, the channel, the brackets, the servo holder, the servo motor, everything all on the sides here, and they kind of highlight on the screen as they move, as you select each one. So let's start by assembling this thing. Okay, first thing I want to do, I think, is let's put the servo into this little guy, and let's mount the servo, this little bracket on the side of that. So easy way to do that. We're going to do mates. So we're going to take this surface right here. We're going to take that surface right there, and we choose mate. And there it looks good. So now slides back and forth on that, no problem. Next thing I want to do is I'd like to Let's just line up with one of those holes. So I'll choose this hole and that hole, and we'll make them concentric. That means one inside the other. And we'll say yes, and you rotate that around. Okay, so we're still not 100% secure, so we'll do one more mate. I'll choose this edge right here and control that edge, so I've selected both of them. I choose mate one more time, and we'll make those guys parallel. Now this thing's nice and secure. I can take it, I can't move it. Now, the only thing that's fixed on this screen is this original channel right here. And if you look right here at all the individual parts, you'll see the first channel that I put down has got an F right beside it, and that's why it's fixed. It doesn't move. If I was to right-click on that and say float, I would be able to move it. But I don't want to move it. I'd like to keep it fixed. So I'm going to take it, I'm going to fix it again, and now it's locked. Okay, let's get that servo mounted on there. So best way to do that would be these faces down here. This face has to line up with that face. So I use the control key and I select both of those two faces. I'll mate them. And I'll just make them coincident. That's fine. Okay. Next thing I want to do is take this little circle here and this circle, and we'll make them concentric. Right? And we're just about there. Now this thing still rotates like that. So we're going to have to constrain it one more way. I could probably use these two circles here, but I don't know if those holes line up 100% accurately. And if they're out even the tiniest bit, I can't make them both concentric at the same time. Safer for me to just choose this edge right here and choose that edge right there, and I'll make them parallel. Okay. So now this is fixed. Okay, let's put the horn on here. So I'll just put the horn a little closer. Lift it up here. Now what I want to do is take this face right here, this little face, and I want to attach it to the face inside the horn. See if I can see inside. There it is. So I'm going to take this face right here and this face right here and make them coincident. And we say yes. And now they're coincident, which is good. Now we want to take this circle and that circle, and we want to make them concentric. And we do that. And now it looks to me like the circular horn is connected and it rotates. All right, let's get those swing arms put on there. So I'm going to take this swing arm here, put them outside. Let's see, how am I going to do this? If I take this one and that one, and we make them concentric, that should work. Now let's do the same thing here. So let's take this one and that one and make them concentric. Oops. So those holes didn't quite line up the way we wanted them to. So let's try it again. This hole and that hole, mate them, make them concentric. There we go. Now it's just about there, except it goes up and down, but it's over the right, it's aligned over the bolt holes nicely. So I'm going to choose this face, and I'll choose this face, and I will make them coincident, make them touch like that. All right, there we go. Oh, beautiful. That's working really well. Okay, now let's take this one right here and that one right there, and we will make them concentric again. Okay, good. Now they're concentric, but they still have vertical movements. So we'll take that face, and we will make them coincident, line them up like that. And now both of these are connected. There we go. This is working fine so far. Now, of course, I can go ahead and put some bolts and nuts through there to make it look like it's actually attached instead of logically attached. But we'll do that some other time. Now what I want to do is I want to take this right here and mount it on top of that. So to do that, let's see now. Let's take this face on the top of the edge there and the bottom of this platform right here, and we will mate them. Let's flip it around so it mates on the top. That looks good. Let's make this edge and that edge parallel. All right, that looks good. Now that should be sliding back and forth. They're parallel. Wonderful. Last mate I think we can do is let's choose this face and this face, and we'll make them touch like that. And now we have constrained this thing to moving nicely along this axis. All right, let's bring this sucker around and attach it to a suitable hole. That looks like a good one. All right, so we'll say, let's take that hole, that circle, and that circle right there, and we will make them concentric. And we'll say yes. Now, they're not really physically connected, but they do actually work together. Now, I mean, a person could take a couple of these grommets and attach them here and here and maybe put a bolt through it and a nut through it. It would look really nice. I'm going to leave that for you guys to worry about. In the real model, you might actually have a little angle bracket channel along here to kind of hold it in and out, maybe a bracket over the top to hold it down. Again, I'm not going to worry about that right now. Now let's put the stop in place. So what I can do is let's take this circle and that circle. We'll mate them. We'll make them concentric. There we go. It looks really good, but it still moves in and out. Concentric. Okay, so now this thing still moves in and out. We got to fix that. So let's choose that face right there and whistle around to this side. Choose this face right there, and we will make those coincident, and say yep, and there we have it. Okay, so now unfortunately we're not quite done because this thing will slide right through there. It'll go as far as it can with this arm, but it doesn't stop at this bushing. Okay, so let's fix that. That's another special kind of constraint. This is called we're going to set up a linear constraint. So now what I'm going to do is we're going to go mate, and we're going to choose an advanced mate. And we're going to choose this kind of an advanced mate. And we're going to make the minimum distance, I don't know, I think about 2 centimeters. And the maximum distance, I don't know, it doesn't really matter, 50 centimeters for the maximum. And it looks like I hit the button twice, so let's do it again. So we're going to do this kind of a mate. Again, minimum distance 2 centimeters. Maximum distance 50 centimeters, more than enough. Okay, and we're going to choose our surfaces. So it's going to be between this one and this one. All right, and we'll say yep. Now theoretically, now this thing can only go in 2 centimeters. Now it looks like it's actually bumping into my bushing a little bit, but I'm going to just forgive myself. I could have probably stopped it a bit later, but just playing with that second number, minimum number, I could have fixed that. And if I stretch it out all the way, it's never going to get to 50 because this arm doesn't go long enough. There we go. Okay, so here we have a very simple linear actuator suitable for pushing buttons in an FTC challenge. So I hope this little demonstration makes good sense to you. And I want to thank Mitch for putting together this little challenge for everybody. Have fun. I can't wait to see what kind of designs you guys come up with. Talk to you later.